All right, we're getting started. But before we get started, let me thank one of our sponsors, Trust on Cloud. They are a silver sponsor for Forward Cloud Stack. We do appreciate their support. Trust on Cloud, so hot right now. Sorry, somebody owes me a beer for that. That's why I did it. Accelerate your cloud journey with the right controls. Trust on Cloud provides an exhaustive threat model for the cloud provider services, e.g., Amazon S3, Google BigQuery, Azure OpenAI. To discover the right controls required to mitigate any identified threats, trusted by global systemic banks, Fortune 500, and defense agencies, customers use our products to accelerate their service onboarding, service security assessment, and service allow listing processes, which they have found can reduce the time to adopt new cloud services up to 70%. Additionally, Trust on Cloud allows you to continuously monitor and address any gaps in control coverage for your existing services, ensuring you meet your risk appetite and stay current with the changes in the cloud services. All right, let's get started with our talk. This is David Challoner.
5 terabytes of data.
No problem. We are Google. 5 terabytes is so little that I've forgotten how to count that low.
Great. I'll use App Engine. That will be easy.
Very easy. Just register an App Engine account, write a little Python, write unit tests, write a regression test, write an end-to-end test, create a CL, pass the submit queue, get the CL approved, wait for the build to go green, and submit it.
Great. That will only take a week. By the way, my data is generated by an internal cron job. Will that be a problem?
This is Google. You'll need to store the data in a big table.
That's kind of a pain, but...
All right. It's a little antiquated at this point, but you get the idea. So hi, yeah. The objective here is, this is kind of it's called a LoRa, or a life of a request. So it's kind of like an exercise, just follow the life of a request throughout its journey. In this case, we're just going to try to make a request to an application that talks to a database. And like this video, should be simple, right? It shouldn't be too hard. This is Broccoli Man. It's a staple inside Google to kind of like highlight some of the extra hops we have to go through to do simple things. You can Google it. I think that one has leaked on YouTube, so you can find it yourself. So hi, my name is David. I'm a TL for Google's regulated cloud. So we power a thing called Assured Workload, which makes it easy to have like a compliant Google project for different like compliant regimes. I've also worked on a bunch of different security and access control stuff, like endpoint verification and Beyond Corp style controls, and also some storage systems as well. That's me with my dog Eva. We're backpacking. So the title talk, Bulletproofing Your Cloud, Lessons from Inside the Borg. You can hit me up at my Google email address or LinkedIn. I workshopped this title with Gemini, so it's a little clickbaity. You know, that's probably why. Story of Beyond. So this is kind of how we're going to break up the talk. Beyond Corp, Beyond Prod, and Beyond Access. You kind of think of this as protecting the IT security perimeter, workload isolation, workload protection, and then also protecting access to customer data. So the last one is what I work on a lot today, but I've worked on all 3 of these things. So Beyond Corp. So this is something this is an article we published in Login, I think in 2014. I don't have my speaker notes here, so I'm just kind of like improvising. So this is about building a zero trust IT security perimeter. You have like all these components, right? So your devices all report to a data warehouse. They usually have some agent or plugin that's collecting all the facets about the device, all the different pieces of information. Those go into like a trust inference pipeline, and then that kind of outputs like go, no go for the proxy to like the trust level of the device. So you want, these days you also want things like cryptographic attestation. I think the YubiKey, there was another talk that talked about that, but you want kind of quoting the inventory of the device to make sure it's an approved boot configuration. So those are the sort of things you can do today to kind of have at the IT security perimeter to verify that the device is owned by the organization and running an approved configuration. So this is where we start. So an enterprise user sends a request to a service. We're using an enterprise user here, not just a normal end user. So I know Google has kind of both. End user is kind of like a superset of the normal requirements. So that's kind of where we're starting. It kind of looks like this. So like the red squares are kind of authentication barriers, or where we have like different systems. So end users and admins use a system identity system called Gaia. Google privileged users go through something called corp, and once they're in corp, they usually, so like that, in order to get into corp, we'll talk about it, but they need a memorized secret and a hardware security key, and from going from corp to prod, they need an additional certificate. So these are the sort of things we go through when they kind of pass these authorization stages. So they have, is this an obvious attack or DDoS? Who is this user? If you have, we have the YubiKey here, we have to prove pointer, that someone's actually at the keyboard, and we do some basic authorization checks. We can't do all the checks here because we don't know necessarily what resources or data they're going to eventually access. So we can talk about that in the beyond access about how we do target extraction. But for now, we can do some like basic authorization checks at the identity proxy layer. And then, like we talked about, we apply these beyond corp controls. So I think we just talked about this, but we have all these devices reporting to our data warehouse, and we're trying to build this like understanding of all the devices. In the bottom right of these slides, I do have some like implementation ideas. Because I work at Google, I am familiar mostly just with Google projects, but I did try to throw in some open source options. But basically, yeah, this is something that I think most you can find outside Google and other cloud providers as well. So like, the streaming data pipeline kind of determines trust level, and then the perimeter proxy can look at that and kind of make a decision on whether the device should be allowed. So here's some of the controls. Is the device owned by the company? Very simple. Is it running an approved IT configuration? Is it sufficiently updated? So like, if you don't apply your OS updates, eventually you start getting emails saying like your device is going to be locked out. You're not going to be able to do your work. So it's important to stay on top of your OS updates. Running endpoint solution, endpoint management solution. So like, Google has its own versions of those. Those need to be running for it to be a trusted device. And then lately we can do things like cryptographic attestation with TPMs. And so that's all even stronger, proof that the device is, like running an approved configuration. There's also some other things you can do here, like EU worker law, I think prevents users from working too long, so you can do stuff with that as well. This is just a quick slide saying that if you have an identity proxy, you probably want a firewall to make sure that applications actually use it. So that's something like we have here is that when we cross these trust boundaries, we have these policy enforcement points. Those are controlled obviously, by declarative rules and source control. And so here, we have firewalls. They have to use the default deny, and then we make sure that all traffic ingresses through the identity proxy. Moving on, this is beyond prod. So like this is kind of moving on to the workload isolation, even when running on the same host. How to ensure that you don't have like the trust between services. Again, going back to this zero trust model. There's no kind of like safe or like VPN style trusted network. Everything is zero trust, and all code run has known provenance, and then all these other things like consistent policy enforcement, and then again going back to trusted hardware and attestation. So this is kind of like the SSCI levels we think about. So you can start with the lower levels. You might see these in a non-prod kind of dev environment, or like on people's laptops or something where there's like no protection and any code will run. We go from like that to provenance, where we start to have some levels of protection, tamper protection, identity of artifact builder, and you can see we kind of escalate the chain up to the point where not only is the startup configuration two-person reviewed, but it's also startup and runtime configuration. So that's like the highest level. So things that touch business critical data at Google need to meet that highest level. Even in emergencies, so we can talk about how we do that in emergencies, so there is no break glass. So here's kind of a simplified version of the CI/CD pipeline. So if I'm a Googler, I author a CL, I send that to my teammate, where you have two owners over that code path. He LGTMs. If one of us has readability in that language, it will get submitted to the code repository where we can do, or first we'll do a bunch of pre-submit checks to make sure that static analysis, linting, tests, all those things to be run before the code is submitted. Obviously, once it's submitted, it can be built by a system called Forge, like a distributed build system, and then pushed usually to like an auto push environment. So usually at Google, teams will have their service, on an auto push and then promoted to prod, kind of like on a weekly cadence. And prod rolls out over like 4 days, so you're pretty much always pushing to prod slowly over time. And like that's kind of like the S3 model, right, where you want like the slow change that's very deliberate. So you can see here, it's like we have this is the other view. We're using gvisor for workload isolation. So you can't like build everything. So as much as like some companies may try, like not invented here, sometimes you do have to run things by third parties. So we have to make sure that the other application meets our SSCI requirements. Here are some of the questions we might ask and things you can ask of your vendors. Do they do these things? Do they approve they do these things? Are they proactive? One interesting thing I just learned about was a thing called Assured OSS, which is basically getting access to Google's third-party library. So when we use code at Google, we vendor it in a third-party library source in the source control system, and it goes through those same steps we just talked about with the two-person review. And so you can kind of just, this is like turning sawdust, I guess, into charcoal, where they're turning that into a product they can sell, and that's basically accessing all the third-party code that's already been reviewed by Googlers. And so we also apply the SSCI concepts to our infrastructure layer. So we have if you're running in GKE or one of these other compute layers, we have all the code and configuration also have to meet the SSCI requirements. We also have for GKE we have a lot of requirements, like are you using shielded nodes? We just had that previous talk about exploiting nodes with metadata servers, and so are you using metadata concealment, workload identity? We have a lot of org policy and pod security policy things that we apply. And there's an open source thing I point to later that has some of these best practices encoded in it. Another important concept or thing here is GKE namespaces or even clusters are not a hard tenancy boundary. So we kind of make it like a requirement you use the project as a tenancy boundary. So that's just something to keep in mind. A lot of teams will put prod, staging, dev on the same cluster just to save money, which is good. But if you want hard tenancy, you kind of have to differentiate or move things to the product boundary. So yeah, here's an example. It is open source. This is kind of what we use internally for when a Googler wants to use GKE to run software, and it implements some of these things like binary authorization, config sync, policy controller. So these are all products that you can use to kind of enhance the security posture of your Google Compute Engine project, or sorry, Kubernetes engine. So you can take a look here. I think it does require a GKE enterprise subscription, so it's it's not free, but these are some of the products that I think are just mandatory. And also it's another kind of thing here is when I create a GKE cluster, I just fill out a very high level intent in a configuration language, and then that generates the Terraform, and that Terraform then generates the cluster. So I don't go into the Google admin interface ever. It's only read only unless I break glass, and then I can mutate. But that's break glass requires an emergency. So that's something to think about, is that when use high level intent to generate your Terraform, and then your Terraform can then generate your cloud assets, and then as this safer GKE pattern evolves and we add new best practices, we can go and update everyone's Terraform configuration to make sure it includes those best practices. So it's kind of like a rolling version of what we consider the best practice configuration. So just going back to our journey of this request path, right? So the request connects to a sidecar instead of a service. So we use a sidecar because we want to have all these things in one place. This is all written in kind of performant C++ code. It can all be owned by one team, or teams can contribute extensions. And so we just want to write this code once usually. So that's why it's written in a sidecar, and then it uses a local channel to talk to an application process. So these are all the things we have in there. So it implements our policy for application-to-application communication, and then it does rate limits and quotas. It does MTLS, logging, monitoring, and then we'll talk about it, but data access and auditing. So these are all the things you'll find in this kind of shared sidecar process. So you can think about it as this kind of security policy. That this is run in the sidecar. An example I have here is Envoy. So we actually use Envoy internally at Google, and I think it can do something like this. It doesn't have as sophisticated controls, but it's pretty good. So you take the request in security context. It gets authenticated out to the authentication policy. It goes through the authorization policy. So the authorization policy can then call out to these different pluggable authentication systems. We'll talk about those like Zanzibar or Cloud IAM. And that can kind of render a decision of OK or permission denied. So it kind of looks like this. So this is like a fictional fictional cloud project called Jishu. So yeah, you didn't think there'd be a product announcement today, but yeah, Jishu is like this common example we use inside Google to kind of talk through these things. So like end user goes through one of these like either like the Jishu app on the phone or an actual Jishu may be talking to a backend API. Those robots that are talking to either the backend API or internal actors that are usually using some internal tooling to either talking to the API or maybe directly talking to the database. So this could be an example of an unprivileged user or an end user credential presenting user. So these are just different roles to think about. And then once we have the authentication, the authorization is done by like something called Zanzibar. So there's a paper on this. You can Google, but basically this is how you do permissions for like photos or YouTube or these things that have different sharing primitives or access controls. You have IAM, which is like Cloud IAM, which maybe people are familiar with, or the application can have its own kind of local authorization code. But an EU presenter is basically this idea of like you have an end user credential, and I can give you this forwarded credential as proof that I have an end user on the other line. And then we can talk about these admins. So optionally impersonator. So an admin can impersonate an end user, or a system user can impersonate an end user. We try to discourage impersonation these days because it's like there's security implications for that, but there's patterns that are like still supported. And then you have admins that can do EUC perimeters or MPA reviewers. So we can have in your RPC security policy you can say like who can review these accesses. So it kind of looks like that. So you have an RPC from user foo, and that is a forwardable credential from bar at Gmail. So this system is basically saying foo can present these credentials, and then it can be authenticated as bar at Gmail. So that yeah. So that's implemented in the sidecar. The sidecar runs through that policy logic for your system. This is kind of a mix of centrally managed policy, which is like mandatory, that's like sent by the security teams and the platform teams, and each service team can kind of add on to this with their own kind of discretionary team that's specific to their service. All this is also under like the same SSCI requirements. And then, yeah, I think as they talked about in the GKE talk, like all these identities, it's really helpful if they're if the credentials are scoped and non-exportable, which just means like you shouldn't be able to take the credential, it shouldn't be a Barrow token or something that could be exported off of the instance and then used outside of the context of the application. So final section here is beyond access. So this is whenever you want to touch a production control surface or internal customer data, you have a lot higher bar to your data access. And that's because we want the full story, the who, what, where, why, and a valid business justification of the access. And so, as an infrastructure provider, we have an obligation to provide customers with controls over data residency. That's where data is living, where it's being encrypted and decrypted, and then transparency around when that data is accessed, or who accesses it and why. So this slide's kind of doing a lot of heavy lifting. I can kind of walk through it. So you want to know the actor who's making the request, right? So that's the administrator who's kind of accessing this data. And again, we go through this SSCI requirements exercise. The initial thing we were doing is basically, is this a valid business justification? And is the access non-unilateral? That just means have two people agreed that this action is appropriate or valid. So that's kind of the primary mechanism we use to validate a business justification, is just to have another Googler validate it. We do use the ticketing system as one way of doing that, and we'll talk about that as some of the these are the different controls or additional policies you can implement. And then we do target resolution, which is what is the actual thing you're accessing? This is down to the actual database level. So if I'm querying the database, I'm getting, these are the fields in the database I'm accessing, or the columns, or if it's a resource, what resource. So all that is target extraction or target resolution. So each team at Google has to build target resolution into their service so that you can map the RPC request into the actual targets that are being resolved and the data being extracted and given or sent back over as the response. And then if it's a privileged access, which these are, we have this failed close logging to audit. So if you can't audit the request, if you can't write to our audit logs, then it doesn't, the request dies there. So that's a hard dependency, and that's because we need, we have this obligation to process these logs and tell customers when their data is accessed. Yeah, and then we talk about like how do we support emergency break glass or low dependency access. So we have zero dependency or low dependency versions of these systems so that you can kind of run them on top in what's called like an MCP or like these SSH bastions that are only accessible through emergency credentials. And so you can spin up a copy and operate in memory and kind of do a lot of the same things in memory inside of a bastion host. But again, that's only done in emergencies, and there's also audit involved in that. So here are some of the controls you want to be able to like implement. So like were we able to resolve the target? And sometimes target resolution is tricky because it's like it's recursive. So you have a resource, and that's like a disk is access to a VM, which could be access to a managed SQL database. So that you just have to be careful and be able to like fully resolve the resource and understand how what products are impacted. And did a bug get referenced in the reason? So like this is like the reason they pass. And so we try to make it like not onerous for like teams to like do their job. And so, but like, we also have to have this balance of like we want valid business justification. So, usually you just have to pop in like a bug ID or a customer support story ID into your request, or we have sometimes like Chrome extensions to like pull that out of your tab if you have the tab open. And then we can kind of do on the back end, we can run these checks like, is this an actual open bug? Sometimes there's like it has to be open within the last n days. It can't be super stale. Is the bug assigned to that administrator? Was the bug created by someone else? So that's how you get that non-unilateral check that it's like this wasn't just a bug created by me that I should access this data, and then was that bug reassigned? So there's more to this gets very complicated and nuanced depending on the ticketing system, but that's the sort of thing that you can do to have a NUOC check without making someone bug a teammate for an MPA. And then there's just some other controls we can do, like personnel controls, like citizenship, work authorization, clearances. So these are all things we can check depending on the data being accessed. And then what we can talk about, like access approvals, which is getting the customer who owns the data to approve it. And then there could be like some sensitive customer VIP controls, or do we need enhanced? So we go down the list here. This started as a very simple exercise of just validating the business justification, but then we've added all these additional use cases so that we can have these different like cloud products, like access approvals and access transparency. So this is this tenet of like customers should have visibility when and why their data is accessed. And you should know the target of the access, and then you should also give them this like ability to approve or reject the access in near real time. And sometimes, and also there's like an ability to hire auditors to give them a view so they can do this on behalf of the customer. So I think this is really cool. I think this is like what most like more like as a consumer, I want companies to tell me when they access my data. So I don't know. I think it'd be cool if more companies implemented access transparency. So non-unilateral group levels. So this goes back to like kind of the NOPE levels. NUOC levels kind of go down this escalating curve of basic steps are like there's no no permanent humans in this group, all the way down to MPA cannot be bypassed by break glass. So break glass is this emergency procedure, right, where like it's a page, you have an OMG, but even then I still need an MPA. But like I said, we can do these MPAs on MCPs or on these kind of low dependency bastion hosts. So that means that like there is no excuse. Like you have to build it. For these business critical applications, you still need an MPA. So that's like the highest level of non-unilateral group access, and then and that's what is kind of required by any kind of business critical application. But you can see it's kind of an escalating curve. If you want to implement this, there's no like super turnkey solution, but there are some things that are coming online. Cloud PAM is kind of how to do just-in-time access in GCP. Before Cloud PAM, they actually open sourced something called MPA in GCP, which is like a open source project. And it kind of works with identity aware proxy. So that's kind of another option to consider, maybe for like application level just-in-time access. And then there's also JVS and Lumberjack, which are open source implementations of the services we just talked about that do the justification validation and access transparency. And it has kind of a pluggable, extensible like module system, so you can add your own kind of however you do justifications. I think there's an example of a GitHub issue justification. So this is actually used in production for Verily, Tidal, and other bets. So it is being actively worked on. So yeah, this is just what I work on. So GCP projects have a larger configuration surface, and so how do you ensure you kind of meet these compliance specifications, like FedRAMP or HIPAA or what have you. And so Assured Workloads is kind of how that works. And so these are the sort of things that these compliance regimes require. Like data has to stay in region. Like and Google's a multinational company. It has teams all over the world. So we have to make sure if a team accesses data, like it's not going to violate any of these compliance regimes. Other things we do is like we configure the project for the customer and we monitor that configuration to make sure it doesn't change. And then we also have to do things like disable non-compliant products because there's kind of like a rolling system of like products coming online and being declared like enabled for these compliance controls. So this is something that like you kind of have to also like the difficulty here is that if a customer raises support issues and there's only subject matter experts in a region that isn't allowed by those controls, they have to be able to escalate to another person that is allowed and then kind of walk them through the exercise of resolving that customer's issue. So that's something we're trying to figure out. We've built tools and processes. We're building tools and processes to deal with this. Like one of the things we're building is called Phone a Friend, so you can find someone in the organization that's near you that has maybe the same skill set that is allowed when you might be denied access. So operations is like how this stuff works in practice. So all this stuff is constantly changing. You need a way to manage this change. So like, you want things to be secure by default. You want to give teams like self-service dashboards and denial debuggers. If you get denied, it's really helpful if you have a tool that helps you understand why you were denied and how to remediate that denial. You have policy configuration. Like Google loves to build configuration languages. We have many. Any policy configuration language, it's really helpful if it's integrated into internal tooling. So like IDEs and language and static analysis. So all that is very nice to have. Kind of at pre-submit time, so you know that your change is valid. Can we evaluate what the policy will change? So like this is like replay and simulation diff testing are all very nice to have as pre-submits. So these are all things that we have for like our internal systems. We do want to like add them to our external ones. I think some of them might have these already. Dark launch modes is kind of like this, it's this advisory. So it's just logging if it would have failed, then you can kind of collect these and understand, whether the policies like should be enabled. And then slowly rolling out policies, right? So like all these are constantly changing. Everyone's like adding policies all the time or making changes. So we want to make sure that that we don't break systems. And so we have canary analysis, policy commitment. So we never want to have regressions where things go down in policy. Everything should always go up. So that's one thing we built is kind of like this idea of a policy ratchet. So there's no accidental regressions or for some reason we don't do data residency or like access approvals for a type of product or data that isn't like intended. And then how do you do OMG escalation and IMAG with these sort of additional like kind of controls? So these are all things we kind of thought about and have to build tools or processes around. So here's just a fun story, I know I got 10 minutes, so there's some time. So like I said, these are all complex patterns and they have like many dependencies. And so like we do need these mechanisms for like secure and compliant low dependency access. And unfortunately like these mechanisms are usually like not the same pathways or like tools as like the normal day-to-day tools. So like, and we'll get into a reason like why that's a bad thing. So like in 2012, there was a new GBus password. This was like a Wi-Fi secret and it caused like a stampede to our like kind of our secret storage service called Valentine. Esri ended up restarting the service globally, and because it was very secure, it ran unencrypted storage. That was protected by 2 smart cards and redundant safes in 2 continents. So pretty good. We only needed one of these cards to start the service back up. In North America, Esri opened the safe but found the card didn't work. That was the error they got. And then in Sydney, they found they didn't have the safe combination. It was clept in the now globally down secret storage system. So it had to be opened through less conventional means. So they had to like break open the safe to get the smart card. And so like this is kind of the lesson here is just like because these incidents are so uncommon, it's important to practice these emergency procedures and be careful of cyclic dependencies like this one. Or in our case, Google has a lot of infrastructure that we use like chat or Meet or notes or documentation, and those systems need to be available in emergencies. So we have to have low dependency versions of those. Here's one thing we do. I don't know if it makes sense to implement in your organization, but we have tooling that takes away normal production access. So every now and again, you try to log in, type gcert, it doesn't work. And it's because you're being tested. You have to go through the emergency access pathway to re-enable your production access. So that's something like you're just forced to practice that. So it's kind of like a muscle, and that it kind of makes teams know that they have that like tool in their toolkit. And yeah, this is what we talked about, like with the zero dependency modes that the systems discussed. So we want to make sure that even though we have these like degraded systems, we still kind of have these policy invariants that we have to maintain. Cool. And this is kind of where we're trying to go. This is like building the machine that runs the machine. So this is like compliant by default control surfaces. So like you can think of it as like, you have a playbook, and that playbook usually has you run like one command after another, like imperative execution. We're trying to like make it easier to build kind of intent-driven automation. A pattern in the real world that's like similar to this is Kubernetes operators. And so like here's just an example of like identify and isolate the problematic request to my service. So that might be like a common SRE journey that can be encapsulated into a sort of intent-driven automation that doesn't actually, so like although user data may be accessed, it's not accessed by a human. The intermediary steps are not outputted to the like console or the display. So it's just done through it's supervised by SRE, but it's actually done by a robot. Cool. So this is just like a slide of like, we want to be able to not block end users. So I think we talked about like the Chrome extension we have to automatically extract the justification from Chrome tabs, or other things we do to kind of avoid blocking end users, like the denial debugger is another example. Another thing is like, we want to be very deliberate about when we require these extra steps. So like if you're not accessing user data, then like we don't require these additional checks. Not all applications have this like level of security or need this level of security. And then like ideally like this complication is not just purely a security win, but maybe it gives operational leverage to teams by giving them more inspectability or understanding of how their service works. I think like service meshes can do that. Istio and stuff can give you a much better understanding of how your services are talking to each other. So that's it. This is just a discussion slide. So I got 7 minutes left. I'd love to get some questions. Hopefully that wasn't too long at the end of the day. But yeah, please let me know if you have any thoughts.
Are these controls different between the regulated cloud versus normal commercial cloud?
Sorry, are these tools different between clouds?
The tools and the technology that you talked about, are they different between regulated cloud versus commercial cloud?
Yeah, so they're different depending on whether you're going through which access pathway you're going, like whether you're going, like if I'm an administrator going to Borg versus going to GCP, there'll be slightly different versions of these controls, but we try to have similar patterns in each environment.
Super interesting talk, especially the beyond access part was very, very interesting. Thank you. A quick question: did I understand correctly that all application workloads going to a database also have an Envoy proxy as a in between?
So yeah, the application runs. So this is kind of interesting. So like the Envoy, we don't use Envoy Google, but like that style of thing, the sidecar, they do use this to talk to databases, and like one of the reasons is because like talking to databases is a very expensive or complicated thing, and they don't want to write that client code in every single language at Google, so like, they just write it once in C++, and then they expose like a simpler API, a client API to each language. So they do go through the sidecar to talk to the database usually. It's called like a lamprey process, I think.
Sorry, it's called a what process again?
I don't know if this is like public, but yeah, it's called a lamprey, which is like just basically a fat client that allows you. That's all like the same thing we use for the access control is the same thing. We have a fat C++ client and then a very thin layer in Java and Go and C++ for people to actually talk to it from their applications.
And this design pattern is followed not just for SQL but also for blob stores, NoSQL. So every data store has a proxy.
I'm not 100%, but yeah, Spanner certainly does. I believe Bigtable, or not Bigtable, Big Store does. Yeah, it's a very common pattern to have that lamprey process. And like I said, like we also have that SQL proxy for humans. When humans access data, we go through the SQL proxy, and that tell us like what data they're accessing and whether that data is customer data.
Awesome. Yeah, great presentation. I like this architecture. Kind of in line with what he's asking with Envoy. It seems like you have two service meshes, Envoy and Istio. Are you using Envoy more for application-based prod like connections, and then Istio more for user just-in-time access?
So yeah, we're not using Istio. We are MVP use of Google Service Mesh, which is like a proprietary, is like a version of Istio that is like Google offers as a managed service. It's a little different thing. And we do use Envoy inside of Google as a type of as like a Giphy or Google front end. So yeah, it's kind of confusing, but yeah, we do use Envoy inside Google for other things, and then for things running in GKE that want to talk to each other, that need that sort of MTLS property of, and like in the same policy configuration language, that's when we use it was called ASM or Anthos Service Mesh, and now it's called Google Service Mesh, I believe.
Okay, file on with the just-in-time access then. You made a mention that you have two user accounts that are in charge of every application or every new ticket that you're creating. If that one person doesn't have access, it'll find the next closest one that may have access to that particular information. Is there a way? I mean, it just seems to me like I can just use that as a recon. If I can compromise one person, I can just go ahead and find who else possibly can access this one service. Is there a check for that?
Let's see. So the tool we're building is called Phone a Friend, and again, I don't know if I can talk about it, but basically it's we have this problem where you get denied, and because you're in Switzerland and you're on the Switzerland Spanner team, and this is a problem that needs a Spanner subject matter expert. You need to find a Spanner subject matter expert that also has a U.S. citizenship, so they can access this customer data and help solve this customer's problem, and that's where we use it. But yeah, the idea is could you use that to laterally move through the organization to identify people who, I guess, all it would do is would allow you don't get access, but allows you to give that work to someone else so they can do the access, if that makes sense.
Thank you. For the access transparency, are there any technical controls that users can use to make sure that Google is generating the records, or is it just by policy and terms of service?
Yeah, so there's a couple. Where is that? This guy. I like this Gemini. This is when you ask Gemini to create a picture of access transparency. He has no idea, so I just kind of. But yeah, so basically, there's the fail close auditing. So that's basically one step, right? So if you don't write the audit record into our internal audit log called GIN, then that request is denied anyway. And then there's the access transparency platform, which is the system that replays those requests against our authorization server, so it knows it can match those against the response that actually happened and make sure that the target extraction was correct, the authorization decision was correct, and this pipeline then egresses those logs to either workspace or cloud, depending on whether it's a workspace, access transparency, or cloud, and that will tell you the actor, the justification, the time of the access, where the access occurred, I think, and stuff like that. I think those are the four things. But yeah, there's a data pipeline that tries to make it happen, and then there's also my team actually runs that, and there's actually SLO monitoring to make sure that if any messages are dropped, there's an understanding of why that happened. Sometimes people delete cloud resources or cloud projects or something, and that may cause the message to not be egressed. And so those are the sort of things that we try to track to make sure that we don't have message drops and we actually egress logs properly.
Any other questions for David? All right. Thank you, David.
Thank you.